Many biological materials respond to mechanical forces. They adapt, change properties, or activate useful functions. Inspired by these principles, our work at the NCCR has focused on artificial materials that translate forces into molecular and macroscopic responses.
Switzerland is investing in research with a long-term vision to help shape the future.
The Swiss National Science Foundation funds excellent research at universities and other institutions for a better future for everyone.
National Centers of Competence in Research bring together institutions, fields of research, and people to address important scientific, economic, and societal issues. They develop capabilities, establish networks, and transform entire areas of research.
An NCCR lasts a maximum of 12 years, divided into 3 phases. It is the largest grant in Swiss research, with very few proposals accepted.
At the interface between materials and living systems, new questions emerge. How do cells sense and respond to synthetic materials? How do nanoparticles interact with biological membranes? And how can we design surfaces and soft materials that actively guide biological function?
With a total of 90 million Swiss francs invested, this program created one of the world's largest collaborative research environments in the field of bio-inspired materials.
So in Fribourg there was already a strong interest in material science. University was very active in the field, and the arrival of the Adolphe Merkle Institute in 2008 reinforced this dynamic a lot.
We had the people, we had the expertise, and we had a growing set of projects. So the question was, could this local strength become a national network?
The priority was clear. We needed to put ourselves on the map.
Way before the NCCR call was even launched, we met with a small group of people regularly and discussed the basic idea of the center. Our goal was to define a topic that was timely, credible, broad enough in scope to bring together many professors from the Adolphe Merkle Institute, University of Fribourg, and key partners across Switzerland.
An NCCR could establish our scientific credibility within the university and position us in the Swiss and international research landscape.
The topic bio-inspired materials emerged from these discussions. Nature has developed extraordinary materials over millions and millions of years, like wood, shells, bones, soft tissues, each functionally optimized.
So we wanted to understand nature's working principles and apply them to design new materials to solve some challenges of society.
This was more than a research topic. It was a vision connecting biology and medicine, chemistry, physics, engineering, and material sciences.
Our proposal was accepted in 2013. The center was launched in 2014. It was at that moment that our ideas that we developed over the years became a reality in the form of a national program.
Nature creates color by shaping light. The vivid colors of butterflies, beetles, and many other organisms do not come from pigments or chemical dyes, but from precisely organized nanoscale structures that manipulate light through interference, scattering, and reflection.
Then our network began to take shape, including the University of Geneva, EPFL, and ETH Zurich.
Over time, new research groups and institutions joined the center, establishing the NCCR as one of the most successful research environments in the field of bio-inspired materials.
We developed molecular force sensors and use these to produce polymers that signal damage before they fail. We also created materials where mechanical stress directly triggers chemical reactions. Finally, we learned from nature how to design materials that are both strong and adaptive.
Bio-inspiration already underlies many technologies, from adhesives to high-speed transport. The principles explored in the NCCR also extend into real-world applications.
We developed a deep understanding of how nanomaterials interact with cells, viruses, and bacteria, and use this knowledge to actively guide biological behavior. We advanced bio-inspired strategies for energy conversion and created new platforms for engineering human tissue, bringing bio-inspired materials into the health and life sciences.
we supported startups, developed proof-of-concept projects, and transferred results into applications in medical technology, advanced materials for construction, food, cosmetics, and healthcare.
The center provided training at all levels, from undergraduate students to postdoctoral researchers. One program we are especially proud of is the summer undergraduate internship. Every year it brings students from all around the world to the center, boosting our international reputation.
At the NCCR, we advanced the understanding of structural color and self-assembly in nature and translated these principles into photonic materials with vivid, long-lasting colors. This research has opened new directions in optical sensing, edible colorants, and photonic pigments.
Advancing science also means advancing equality. We wanted to address the gender imbalance in academia, where too many women step away from research careers after completing a PhD. To counter this, we implemented Women in Science fellowships, mentoring, and structural measures to support women.
The NCCR brought together over 300 researchers from more than 20 countries.
We also helped make academic careers more supportive through targeted measures, such as reserved daycare places and dedicated support during pregnancy and for parents.
The NCCR Bio-Inspired Materials activated a real mindset change at our university, inspiring researchers to think big and work together to tackle societal challenges.
At the Faculty of Science and Medicine, the NCCR brought strategic focus, creating a critical mass of research groups in the field of materials science. It transformed our scientific infrastructure, enabling the acquisition of major instruments. It expanded what we can observe, measure, and build.
The National Center of Competence in Research has exceeded all our expectations. It has truly delivered.
We've carried out some amazing science, helped talented scientists to advance their careers, and build pathways for future applications.
Through our outreach activities, we have inspired hundreds of children and teenagers to engage in science.
This is the true impact of such a program. It transformed the way people collaborate and drove the field forward.
The NCCR concludes as a very successful program, and its influence will continue through the people, the collaborations, and the culture it has created.
The NCCR's Legacy Center will live on through a new competence center at the Adolphe Merkle Institute. This center will enhance the expertise, visibility, and international network, thereby ensuring the continued success of bio-inspired materials research in Fribourg.